Okay, number 11. Graph x sine of x. Oops, let's do it like this. From negative 10 to 10, so out here at negative 10 to 10. Looks like it does something like this. And you just do this on your calculator. Make sure you're in radian, radian mode. So it looks like it does this. It does the same thing on the other side. Okay. How many zeros does it have on this interval? 1, 2, 3, 4, 5, 6, 7 zeros. That's the x-intercept. See, at 1, is it increasing or decreasing? Decreasing at 4. So now I've got to look at my scale on my graph. And 1 is right here. So 1, 2, 3, 4 is here. So at 1 it's increasing. At x equals 4, f is decreasing, right? Because it's going down. On which interval is the average rate of change greater? From 0 to 2 or 6 to 8? Well, 0 to 2, again, I'm looking at my calculator on the side here. The average rate of change, I'll draw it in a different color. If I can get the average rate of change is that guy. And from 6 to 8, oops, I'm counting on my scale here. 1, 2, 3, 4, 5, 6, 7, 8. So 6 is about right here. 7, 8 is here. So there's the average rate of change there. So here, the average rate of change is greater. Okay, and on the next video on problem 25, I talked a little bit more about average rate of change at the end of it as to what is that again, briefly. So if you need a little bit more help with that, check that one out. Okay, is the instantaneous rate of change greater at negative 9 or at 1? Well, at 1, the instantaneous is the slope of the tangent there. At negative 9, it is up here, it looks like. So that looks a lot steeper than that guy. Okay, so E is going to be greater at x equals negative 9. That's the slope of the tangent line. Okay, so there is 11, and we got to hit which ones on here? 13, 15, 17. So 13. It says sketch the graphs of the derivatives. Okay, so this is a constant function. What is the slope of the curve at any point here? It's 0, so the graph of the tangent, or the derivative, is going to be 0. So this is f prime. 15. Okay, I'll do it on the same graph in red. So I know at this point right here, the tangent line is 0, 0, 0, the slope of the tangent line. So my derivative graph is going to have a 0 there, a 0 there, and a 0 there. Get rid of these other dots. Does that make sense? Remember, f prime is the derivative. So to the left of this, my slopes are very small, and they're getting closer and closer to 0. Okay, but they're positive, right? So I say very small, I'm sorry, I meant very big, very steep. So it's going to come down here like this and go through at this point. And then right after this point here, oops, the slopes are negative. So they're negative all the way until I get back to here. And they go up like that. Now, why is this the smallest point? Why is this point the smallest point? Because that's the biggest negative slope that I'm going to have in this little region, right? Because it's positive, and then it's negative. That's the biggest negative, and then it's still negative on the section after it, but it's coming back up to 0. Okay, keep on. And then here, from here over, the slope is positive all the way up to here. Where is it the steepest? Where is the slope the biggest positive number? Looks like it's going to be right somewhere in this range in here, right? So it's going to be the biggest positive. Sorry, I keep going back and forth here. At about 2.5, but then it comes back down to 0 here. So it's going to be go up and then back down, right? That point will be the maximum. And then from here it's negative and just keeps getting bigger and bigger. Okay, so this right here, so let me erase this piece. This red curve looks like it's going to be the derivative. Okay, 17. The derivative does not exist at this point. I don't know what the slope is if that's pretty steep. So if I draw it on a separate graph here, it might be easier to see. It's undefined at this point. The slope is positive 2 here, say. Undefined, and then here it's negative. That might be 2 or 3 or 4. Don't really know what it is, but I do know it's positive and it's constant. Undefined at this point, and then it's constant negative down here. Okay, there we go on those.